Hi everyone, today's topic is still based on equilibrium of beams. Like I said on my previous video, we are now dealing with more complex beams now. You can see now from our diagram here that you see that I've displayed for you. Now the reactions have shifted a little bit in just to add a spice on our beams and for your creativity on the other hand. Right now, without any use of time, let us see how we can calculate the reactions on this beam. Let me read the question. It says, determine the reactions of the supports, right, for the beam shown. So you must first decide which one you want to make zero. That is a turning point. So I usually like starting on my left, All right, on my left here, I'll just simply say, let us take moments about L. Moments about L. Moments about L. I hope you're still with me, good people. And then after that, you must just say sum of anti-clockwise moments equals to sum of clockwise moments about L, remember. So looking at the beam here, you must check the direction of forces. So we have 50, which is clockwise about L. We have 85, which is clockwise about L. We have 65 here, which is anti-clockwise about L. And then we have R also here. We have R here. We have R, which is anti-clockwise about L. They go all around, good people, at a certain distance. I hope you have grabbed that concept now, good people. Moment is forced by perpendicular distance. What is that distance? The distance from the turning point to the applied force. Now let us consider all these forces now. Let us consider all these forces. Right. Now, sum of moments, anti-clockwise moments about L. We have 65. Let me just open the bracket. We have 65 multiplied by what? Multiplied by 1 plus R. R multiplied by 4.2. 4.2. Close. So there isn't any other force that is anti-clockwise about L. So we can say equal sign. So now the anti-clockwise moment, the clockwise moment will be 50 multiplied by 1.5, so 1.2 plus 85. They are clockwise. 85 multiplied by 5.2. 5.2. I hope you can see 50 is 1.2 from the fulcrum, and 85 you can see is 1 plus 3 plus 1.2. Now let us now remove the brackets. People, remember, it's important to get this correct, because once you get this equation correct, you're good to go. Right. Now, when you multiply this bracket, you have 60 here. When you multiply this bracket, you must get 442. And then on this side, you have 65 plus 4.2R. 4.2R. So let us solve this. 60, that should give you 502. And then this side, let me just write it down because it's first time. I mustn't skip steps. I mustn't skip steps so that to avoid confusion. Then from here, what you must do now, you transpose 502 minus 65, and then you still have 4.2 R here, 5.2 R here, and then the answer from there will be 437, and then 4.2 R. What you do, you divide by 4.2, 4.2 both sides, 4.2 both sides, 4.2 both sides, and your R value will be 104.047 newtons. That's the reaction, that's the magnitude of R, good people. Now, for the magnitude of L, I would like to change the color here of my pen here, of my ink. I would like to change the color of my ink here so that at least we are on one page and everything is clear, right? Having changed that, let us take moments about R this time. Moments about R. Moments about R. About R. Right. You see, sum of anti-clockwise moments equals to sum of clockwise moments. Right. Now, still on that note, all you have to do now is just to check all the forces that are anti-clockwise or clockwise about R. So looking at this, 85 here, 85 is clockwise about R, and 50 is anti-clockwise, and 65, sorry about that, and 65 is clockwise, is anti-clockwise about R, and L here is clockwise. So look at my arrows around R now. This time we have 85 and L that are clockwise about R, and then you have got 50 and 65 which are anti-clockwise about R. So anti-clockwise we have 65 multiplied by, I'm gonna start with 65. So we have, open the bracket, we have got 65 multiplied by 5.2 plus 50 multiplied by 3. So those are the forces that are anti-clockwise about R, equals to clockwise forces. So clockwise force we have L multiplied by 4.2 close bracket plus 85 multiplied by 1. Right, now when you remove the brackets, you have 338 plus 150 equals to 4.2 L plus 85 plus 85. So when you add the two, this should give you 4.88 equals to 4.2 L plus 85 plus 85. So all I have to do now is just to transpose. We have 48 minus 85 equals to 4.2 L. So this gives you about 403 equals to 4.2 L. of which you're going to divide by 4.2 both sides, 4.2 both sides, 4.2 both sides. And your L should be 95.95 newtons. So good people, that is how you will get the magnitude for both of them. So in other words, so when you add 95.95 and 104, which is 104 is here, magnitude for R, they must be equals to the point loads. Remember, the top ones are the point loads, the bottom ones are the reactions. So good people, I hope we have enjoyed this challenge. If you are really interested in this video, please don't hesitate to add a comment, subscribe, give it a thumbs up. People, I'll appreciate that, and I appreciate the fact that you watched this video till the end, of which I always emphasize that people watching my videos must at least watch till the end, because there isn't anything that I want you to miss. Thank you very much for watching. Let us meet on my next video. Cheers.